Welcome to 2.2, where we're going to focus on addition with integers. So we're going to focus on all the different ways you can add positive and negative numbers. So let's have a look. So if we want to add two numbers, a really nice way to think about it is using the number line. So let's have a look and follow this example here. So if we want to add 3 plus negative 5. So let's just suppose for a second I put this into a real world scenario. Let's say this is money. And let's say I currently have $3. And that's what the plus means, right? And then I add to that $5 in debt, and that's what the negative represents. And then all right, so if I have $3 and then I add $5 in debt, like let's say I borrowed $5 from someone else and I have $3 in my pocket, what's my net worth? Because I owe 5 and I have 3, if I had to pay all my debts right now with the cash that I have, there'd be $2 in debt, $2 in debt remaining. So if we agree about that, then let's go have a look at this problem and let's see how the number line can help us solve problems like this without so much context. So let's add 3 and negative 5. So here's what we do. We read from left to right, so we're going to start our addition from left to right. So we start at 3. So this is our start. And then we go, right? We travel this many units to get to some end point, which is the simplified version. So if we start at 3, we start here, and then we travel. Now, which direction do we travel? Do we travel toward the positive side of the number line or the negative side of the number line? Well, and let me level that out a little bit. There we go, better. So if we have a negative sign, as we do in this case, right, then we're going to travel toward the left. So we start here at 3 with the first number, and then we travel 5 units to the left. 1, 2, 3, 4, 5. And that's where we end. That's the result of the addition. So when those simplify, 3 plus negative 5 is negative 2. And we sort of knew that from the context that we gave it earlier. Okay, let's have a look at the next concept here. So now that we know how to add numbers, we can add any two numbers, irrespective of their sign. So let's have a look. Let's look at all the different ways to combine 10 and 15 as integers. So that means there's 10, and there's negative 10, and there's 15 and negative 15. So the first one is to add the positives. So let's add the positives. So 10 plus 15 is 25. Now let's add one positive and one negative. So I'm going to start at 10 on my number line, and let's see. Let's see if there's enough units here. I think there's probably almost enough. If I make my 0, say, here, so that's 1. Let's see, so here's my 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. 1, 2, 3, 4, 5. So that means this is 15. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's negative 10. 1, 2, 3, 4, 5. And there's negative 15. So I can get a sense of where these values are. Okay, so if I start at 10 and then move to the left 15 units, because that's what the minus means, the negative, it means I'm going to go to the left, right? Because remember, this is the positive side of the number line over here. This is the negative side of the number line over here. So I start at 10 and then go to the left 15 units. So I know I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 back to 0, and I've still got 5 more to count. 1, 2, 3, 4, 5. What's that value? That value there is negative 5. 5 units on the left of 0 on the number line. Now, let's keep going here. So let's combine, and I'll just kind of do this so we stay a little organized. So negative 10 plus 15. So negative 10, let's start over here at negative 10, and then we're going to go to the right 15 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units to the right. And that's 5. Now, what happens when they're both negative? Negative 10 plus negative 15. So I start at negative 10. So I'm going to start here again. And then I'm going to go to the left 15 units. So I'm actually going to start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What's that value? That's going to be negative 25. And I'm kind of running out of room here. Negative 25. So let's generalize what the rules are here. So notice when they were both positive numbers and when they were both negative numbers, the absolute value was 25. So when they were both positive, they went together in the positive direction, so they added up in the positive direction. When they were both negative, they added together in the negative direction. So if you have $10 and then you get $15, you have $25. But if you owe $10 and then you borrow $15 more, then you owe $25. And that's why the signs staying with the numbers really matters. So that way we know, is it something you have or something you owe? Is it east or west? Is it positive or negative? Then if the signs are different, if one's a positive and one's a negative, then what we're actually doing is subtracting the numbers in a sense. We're finding the difference between the numbers because one's going to the positive direction, the other one's going to the negative direction, and however much they overlap is going to cancel out. And the way you can figure this out is you look to see which number is larger. So in this example here, 15 is a larger absolute value number, right? So the negative 15 means you owe more money than you have because it's a larger absolute value number, and so, or has a larger absolute value, and so you're going to have some debt remaining. And so if you start with a larger absolute value that started as a negative, then your result will be negative because you won't have enough money to pay off your debt. But if you borrow $10 and you have $15, then when you pay your debts, you still have $5. So hopefully that makes sense. Practice these. Check your work with a calculator when you need to, and definitely ask for help when you have questions or if you get stuck. So let's do some order of operations problems, but let's throw in some integers rather than just all whole numbers. So example number 5, we're going to simplify 10 plus negative 5 plus negative 3 plus 4. So I don't have any multiplication or division. I have all addition and subtraction. So I know I can go from left to right. So what I'll do is I'll take the first two numbers, I'll combine them, and then I will bring down everything else and do one step at a time. So 10 plus negative 5. So if I have $10 and then I borrow 5, I really only have $5 left. 10 minus 5 is 5 plus negative 3 plus 4. That's just coming down. Then, because I'm going left to right, it's all addition and subtraction right now. I'm going to target 5 plus negative 3. 5 and negative 3, if I have $5, and then I spend $3, I have $2 left. And now I have only one operation. 2 plus 4 is 6. So that's my final answer. Now let's look at this other one here. Brackets, negative 3 plus, in parentheses, negative 10, close parentheses, close bracket, plus, in brackets, 8 plus negative 2, in parentheses, close bracket. And you can see why we have to have brackets in parentheses sometimes, because when we have multiple signs, as in the case of adding a positive and a negative, you can't have plus minus right next to each other, or minus plus for that matter. You have to use parentheses to separate the signs. Once you take away the parentheses, you have to be prepared to combine the numbers. The signs sort of fight it out, and the terms combine into a simplified single value. So that's our goal with this. So what we're going to do is deal with each set of brackets separately and then combine them. So within these brackets here, these parentheses are just separating this plus and minus here. So negative 3 and negative 10. So if I owe $3 and then I borrow 10 more, now I owe $13. Whether I really need those brackets or not remains to be seen. Now, if I have 8 and then I spend 2, I really only have 6 left. And now I didn't really need those brackets, actually. I could have written a similar problem that looked like this. So if I owe $13 and then I get $6 to pay off some of what I owe, right? How much would I still owe? So if I owe you 13 and I pay you 6, I still owe 7. And so one way we can think about this is 13 is negative, 6 is positive, so the signs are different. In addition and subtraction, when the signs are different, the values are competing. One's going left, one's going right on the number line. So you can find the difference between the numbers. 13 minus 6 is 7, and then it gets the sign of whichever number was actually a larger absolute value in the first place. And so since 13 had a larger absolute value, it's the bigger number in a sense, and so it's going to win. You have more debt than you can pay off, and so that's why it's still negative once you actually take it back to the problem. So you can make the calculation over here. The difference between 13 and 6 is 7, but which sign does it get depends on whether you started with a larger absolute value that was negative or that was positive. All right, example 7. It's pretty similar, except we have a variable expression. So let's have a look at this. So it's negative 10 plus x. And now what we're going to do is we're going to evaluate this for x equals 4 and x equals negative 7. In other words, here's a variable expression. Plug in the different values of x one at a time and see what the result would be. So here's how we do that. We say, okay, we have this original. Then what we're going to do is we're going to substitute for the variable whatever value they're telling us. In the first place, they're telling us use 4. So negative 10 plus 4. So if I owe 10 and I pay off $4 in debt, then I still owe $6. Now let's do the same problem, evaluate the same variable expression, but instead of using 4, they now want us to try it with negative 7 and see what the result is. Now if I owe $10 and then I borrow 7 more, how much money have I borrowed in total? I've borrowed, we can all agree it's debt, and instead of 10 and 7 separately, we're going to combine them, consolidate them into $17 in debt. So let's review some of the concepts here. So how would you use the number line to add 3 and 5? So this is going all the way out to 10, so there's 3. So what I'll do to add 3 and 5 is I'll start at 3, and then I'll move 5 units. Which way? In this case, the 5 is positive, so it's going to move to the right. So I start at 3, and then I move to the right 1, 2, 3, 4, 5 units. And I land at 8. And that makes sense because 3 and 5 added together make 8. And this is a way I can show it with the number line. So that's A. Let's have a look at B. If two numbers are negative, such as negative 3 and negative 5, what sign will their sum have? So negative 3 plus negative 5, if I add these two together, what is the sign of the result going to be? It has to be negative because I started negative and then I went more negative. And so the result has to be an even larger negative value. C. If you add two numbers with different signs, how do you determine the sign of the answer? Well, let's look at this example. I guess I didn't really need the parentheses here. So negative 3 plus 5. So they have different signs. So one is debt and one is income, and so they're working in opposite directions. So how do you find the result when the two signs are different? That's right, you find the difference between the two numbers. So the difference between 5 and 3, 5 minus 3 is 2. But what sign will it have depends on which number had a larger absolute value. In this case, 5 has a larger absolute value and it's positive. And so then the result will be positive. And that kind of makes sense because if you owe $3 and then you earn $5, if you pay your debts, you'd have $2 remaining in the positive. Okay. D, with respect to addition with positive and negative numbers, what does the phrase two negatives make a positive? Does the phrase two negatives make a positive make any sense? So the only case when two negatives make a positive makes any sense in addition is when we're talking about maybe finding the opposite of a number. In this case, the opposite of 3 is negative 3. But the opposite of negative 3 is 3. So in this one instance, yes, but when we're talking about addition, it's hard to see how that would apply. So hopefully that clarified addition with integers for you, and we'll see you in 2.3 for subtraction.